Hello, guys. Welcome to the series of electrical drawings with E-Plan. At the beginning of this video, I just want to make it quite clear that in this series, we're not really teaching people how to use E-Plan, but I've realized that it's so much easier to learn how to use a software if you're really observing people who are doing so. But what's hard is actually sitting down and actually applying what you've learned in a real life situation. So what I've done here is I've just created like a document. Can I say a series of videos that I'll be explaining, what is beyond, learning A-Plan, because I've seen a lot of courses out there that teach A-Plan as it is, and then after that you don't know what to do with your skills, and after that you don't know what goes around. So I'm just going to be trying to the best of my abilities to just try and explain what we're doing when we're making electrical drawings, and selection of cables, protection and switching devices, and so on. So I just started with this small presentation, and it is going to give us an overview of what we're going to be looking at in this series. So thank you for joining, and thank you for deciding to start this series. My name is Ashpal Tabanda, and I created this presentation, and I hope you enjoy it and you get to learn beyond what you see from other courses. All right. So what I want to start by is just explaining the scenario that we have for this series. So at the beginning, I explained that we have a certain scenario that we have to move along with, and with that scenario, we're going to be selecting devices, and we're going to be creating various things, and just according to that, everything is going to be done. So as you can see here, there's a lot of several electrical motors that are listed, and all of them actually have a supply voltage of 380 volts, and they only have different methods of startup, and they have different rated powers. So the first one is a 3 kilowatt 3 kilowatt pump motor that has a direct online startup. The second one is an 11 kilowatt with a star delta configuration, for startup. So we also have 1.1 kilowatt valve motor with a forward reverse capability, and that is also a direct online, so there's really nothing special about it, but we need some forward and reverse contactors. And here we have a 45 kilowatt pump motor that is started using a soft starter. And then last but not least, we have a 45 kilowatt pump motor with variable frequency drive connected to it. So what we've done is here we've taken several configurations that electrical motors can be started or maybe can function under, and we've listed all of them into one scenario. I don't know if it's really applicable, or maybe there are some places where you can see this, but it's really rare to see all these kinds. Usually, depending on the application in the industry, we see different startup methods. For example, you can have a direct online startup, and that is all they'll have, or you can have a VFD setup, and that is all they have. So with this hardware, we have to make the necessary switchgear selection for the above electrical motors, and all design is going to be done in one electrical panel or one electrical cabinet. All right, so I just want to explain that during this series we're going to be using E-Plan. I had written AutoCAD, but I realized that E-Plan has actually the capability of doing what AutoCAD does, so we won't need to use AutoCAD. We're just going to be using E-Plan Pro Panel, and we're also going to do the 3D modeling in E-Plan, so everything is just E-Plan. All right, so this I just wanted to create a better vision of what an electrical panel looks like for those people that don't know much about it. And we just have the devices here and the cables and the wiring. So this was for a simple, it was for a crane motor actually. It was a single motor that was connected. And this is for the control circuit. We have some relays, we have some circuit breakers, and we have some power supplies, a transformer, another circuit breaker, a motor protection circuit breaker, and a contactor. So nothing really complex. And this was the end result. So we did this, me and my coworker, Eren. Shout out to Eren if he's watching this video. And he's a really great person, and I've learned a lot of things from him. And all right, so I created something like this, a schematic of what connection we're going to be having. So as you can see from the top, we have a single bar that is connected to all these electrical motors, and since we have a constant supply to all of them, we can have a one feeding bar, and that is a 400 volt main supply. So what I want to touch on is that, this is easy, just drawing lines and stuff like that, right? But there's actually an engineering perspective that comes here, where you are selecting the protection devices, you're selecting the switching devices, and so forth. So these are the different types of electrical motors that we have in our configuration. So I just selected different pictures to just make it look more realistic. All right, so as I was saying, just drawing is not enough. You need to show the switching and protection devices. So I'm just going to be explaining the different protection devices that we're going to be using, at least for this basic configuration. So here we have an MCCB. So these are molded case circuit breakers. Usually they're used for heavy current and industrial applications. And you might be wondering, what is the difference between an MCB and an MCCB? So I just want you to know that MCCBs are used for higher currents, so higher breaking currents and tripping or triggering currents. As you can see on top of this, on this switch here, it's written 63 amps. So this is the nominal current which it can function. But then they also provide short circuit protection. So they have really crazy ranges of up to 10K, from 10K to 200 kiloamps of short circuit protection. So they are really like heavy industrial usage type devices. And here we have a miniature circuit breaker. That is the general MCB. This is used, frequently in industry, but then it's just to cater for, lesser currents. For example, for tripping or triggering currents, we're talking of 1,800 amps as compared to the 10,000 to 200,000. So you can see the difference, but they both have a thermomagnetic property. The way they trigger, the mechanism is just the same. It's just that you can see this is a more robust device as compared to the MCB. And both of these are 3-pole, as you can see. So how are they connected? So as we can see, as we said before, that MCCBs are used for higher currents and MCBs are used for low currents. As you can see here, we have the main supply. It's going through an electrical meter and then through the MCCB. And then after that, the individual loads are connected to to the miniature circuit breakers. So you can clearly see from this demonstration that this is catered for lesser currents, and this is for the heavier currents. So in the case of a fault in any of these loads, the short circuit current is going to pass through this device and also this device. So you're providing double protection for your system and also for your load. And then we have fuses. Fuses are amongst the devices that we use a lot, both for protection against short circuit current and also protection, and also like for switching cases. If we want to do like a maintenance checkup, we can use knife type fuses to disconnect from the main supply and so forth. But then these just work like the normal fuses that we have in our houses. just the same mechanism and same characteristics. It's just that they have different shapes and sizes, and also you can tell from the sizes they also hold different. They have different current carrying capacities. And I also want to state that it is not advisable to protect electrical motors with fuses only, because fuses do not provide protection against overcurrents. They only provide short circuit currents. So if you're going to use a fuse to protect an electrical motor, you have to also provide, uh, an overcurrent relay or something like that that can make the protection for overcurrents, because just like that you can cause problems to your hardware or your electrical motors or loads. So here I want to talk about RCCBs and RCDs. These ones generally do the same thing. RCCB stands for residual current circuit breaker. RCD is residual current device. So these devices just check for leakage current. So when there's a leakage, maybe somewhere along the circuit, it means that the amount of current that is leaving and the current that is coming back are different. So it looks at this difference, and if it is bigger than a certain amount of, usually 300 milliamps, then the device is going to trip and provide protection. This is usually used in houses, or to protect people from being shocked and stuff like that. This is a combination of an MCB and RCCB. That's a residual device with overcurrent protection. So for overcurrent, we know that we use MCBs. RCCB is for residual current, and they somehow just manage to combine it into one device. And then one of the most important devices used in the industry are the phase protection relay. So phase protection relay just protect from single phasing. So single phasing is a scenario where one of the phases is disconnected per se, and it's not a favorable condition to feed a three-phase load with a two-phase or single phase. This can cause overheating problems and even like short circuit faults in the system, and this is not something that is favorable. So this device checks if all of the phases are still in use, and then if one of the phases is out, then this is just going to send a signal to the contactor or to some switching device so that it triggers and disconnects the load. So here is an example of how it is connected. As you can see, we have L1, L2, and L3 that are connected to the phase protection relay. So let's say this L2 is no longer working, or maybe there's been a breakage, or I don't know, anything can happen to this line. So it means that this load is going to be supplied by only two phases, and that is not good. And you want to prevent that from happening. So what you do is just, this is just checking all the phases if they're open, and it sends a signal to this contactor, which is just going to open up to protect the load. All right, so this is it from me, and I just want to say thank you for joining this course. And on the next lesson, we're going to be looking at how to start with E-plan and drawing stuff. All right, thank you.